Hi everyone, we're continuing with our trek through 4.7 on inverse trig functions. We're now going to consider the graph of y equals inverse cosine of x, or arccosine of x, which means the same thing. Now, over on Desmos, let's take a look at y equals cosine of x. We need to grab a piece of this cosine wave that is as tall as the original cosine wave, so we keep the same range, but it's got to pass the HLT, the horizontal line test. We all agree that we start here at the point 0, 1. Now we can't move around this point because we're going to fail the HLT if we move to the left and to the right at the same time. So we're going to start at 0, 1, and we're going to move to the right. And where do we stop? We have to pick up the entire range. We're going to stop here, because then we'll pick up the entire set of y coordinates from -1 to 1, the entire range for the original cosine function. We can't go any further because if we go any further, we're going to start failing the HLT. So we all agree that we're going to grab the piece of the cosine graph from 0, 1 to pi, -1, and we're going to restrict the domain to the closed interval from 0 to pi. Now, remember that when we go from a one-to-one function, which this now is, to its inverse function, the domains and the ranges switch. So remember, going back up here, and I'll put this down here, the domain for the red graph is from 0 to pi, the x-coordinates. That's the domain. The domain for the original function, meaning the restricted cosine function, becomes the range for the new inverse cosine function. The old range, the y-coordinates from -1 to 1, that becomes the new domain, the closed interval from -1 to 1. These are all closed intervals here. Again, for a one-to-one function, like this restricted cosine function, and its inverse function over here, the domain of one becomes the range of the other, and vice versa. Also, the point AB becomes the point BA. So when we graph the inverse graph, I'll put these side by side, the restricted sine graph is in red over there. The corresponding inverse graph for the inverse cosine function is on the right. 0, 1 goes to 1, 0, which is on the right over here, the rightmost point. This x-intercept at pi over 2, 0 now becomes a y-intercept at 0, pi over 2. The point pi, -1 becomes the point -1, pi. Again, domains and ranges switch. The domain from 0 to pi becomes the range from 0 to pi on the y-axis. That's why this graph never falls below the x-axis here, because the values in the range are non-negative. Likewise, the range from -1 to 1 here becomes the domain from -1 to 1 here. Like for the case of sine and inverse sine, the original red graph goes flat near its endpoints, so the inverse cosine graph goes steep near its endpoints. And this is the entire graph. You're looking at the entire graph for y equals inverse cosine of x. The tangent line there, the tangent lines here in green, you may not want to actually graph. They're just there to indicate steepness. But you are looking at the entire graph. It has finite arc length. The inverse of a decreasing graph or function is decreasing. So x and y are going against each other this time. Now this graph is symmetric about this x-intercept, so this graph is symmetric about its y-intercept. Bear in mind, this restricted cosine function is not even because we're not allowed to go to the left of the y-axis. All right. So here is the graph of y equals inverse cosine of x, or arccosine of x. We can go to Desmos. Remember that the fractions of pi tend to go on the y-axis. Now, y equals arccosine of x. Finite arc length. We go from this point, -1 comma pi, to this point, 1 comma 0. And it's going down. All right. Now, what about a restricted tangent function and its inverse? Let's consider the graph of y equals inverse tangent of x, or arctangent of x. Well, the graph for y equals tangent of x is a zoo of snakes, and we all agree that the piece that we want to invert is this middle piece over here that goes through the origin. So we're going to invert this proud rising snake. Remember, we have VAs at x equals -pi/2 and x equals pi/2. So when we invert this proud rising snake, what do we get? Well, again, the domains and the ranges switch, and guess what the VAs become? The VAs become HAs. So the VAs at x equals -pi/2 and pi/2 become HAs now at y equals -pi/2 and pi/2. The rising snake here is tall and proud. The snake here is rising. The inverse of an increasing function is increasing, but it's not so proud. It's a lazier snake. It's more of an S graph, kind of like for cube root. This graph in red gets steeper and steeper near the VAs. This graph in blue gets flatter and flatter as it approaches the HAs. There's only one really key point here on the red graph, 0, 0, and it goes to 0, 0. There are other points like 1, pi/4, but we tend not to use the frame method here. We tend not to identify the quarter points so much on inverse trig graphs. Again, the restricted domain here, you see, is from the open interval, from -pi/2 to pi/2. The range, the y-coordinates we pick up, all real numbers. All y-coordinates, all real numbers are picked up as y-coordinates. So again, the domain is the open interval from -pi/2 to pi/2. That becomes the range for the inverse tangent function. The y-coordinates we pick up here. The x-coordinates here in red are the y-coordinates here in blue. The range here, the y-coordinates we pick up here, all real numbers, becomes the domain here, all real numbers. And notice, unlike the other two guys, this inverse tangent graph is infinitely long. It has infinite arc length. It goes on forever and ever. The range for restricted tangent, all reals, becomes the domain for inverse tangent. These sets switch. On Desmos, when you graph y equals arctangent of x, it goes on and on and on, approaching the HAs at y equals -pi/2 and pi/2. All right. Now, you can reflect the middle tangent snake about y equals x to get the inverse tangent. Lazy snake, the S graph, is kind of hard to see, but you could reflect about y equals x. In the next video, we're going to talk about a shortcut for finding ranges. Before we do that, I want to mention that for inverse cosecant, inverse secant, and inverse cotangent, we're not going to deal with the ranges so much of those, or the graphs, because they're controversial. In fact, you might have different ranges in a pre-calculus book versus a calculus book, because they're different purposes. So we will not discuss the ranges for inverse cosecant, inverse secant, and inverse cotangent, because pre-calculus and calculus books will differ. The ranges for inverse sine, inverse cosine, and inverse tangent, as we discussed before, these are not controversial, and we'll discuss a shortcut for remembering them in the next video.